Ladies and gentlemen, my name is Jukka Hast and I'm working at VTT Technical Research Center of Finland. Title of my talk today is Towards More Sustainable, Flexible, Printed Sensors and Systems. At VTT, I work as a research manager on Sensing Solutions research area and I'm responsible for strategic research in this area. We are about 150 people focusing on printed and flexible electronics and photonics, biosensors and diagnostics, as well as optical instrumentation for different industrial applications. This topic, sustainable, flexible, printed sensors and systems, is very important for us, and we have been working on that more extensively now about 5 years. Primary mission has been to replace existing fossil-based substrates with different bio-based, renewable, better recyclable or compostable substrate materials. So far the journey has been very interesting, but I have to admit that we are only in beginning. There are a lot of needs to develop new technologies on our way towards more sustainable world. Here is the contents of my talk. I will briefly introduce VTT and our research in flexible and printed electronics, as well as our research infrastructure. I will talk about drivers for actions to decrease environmental footprint of electronics, as well as drivers and tools for sustainable flexible electronics. I will introduce several research examples in this topic, including structural electronics based on foam-forming technology, structural electronics based on biopolymers, printed paper-based hybrid electronics, and here I'm using SuperSmart project as an example. I'll talk about graphene, a sustainable raw material for flexible and textile integrated electronics. I will also introduce Ecotronics project, which is our major national activity ongoing. I will finish my talk to summary. In Finland, the government has set ambitious target to be carbon neutral by 2030. This is driving VTT to create sustainable growth at all sectors of technology by tackling global challenges. Sustainability in research content and solutions is at the core of responsibility at VTT. VTT is governmental research organization and today we are a bit over 2,100 people working in all sectors of engineering. We are under the Ministry of Economic Affairs and Employment, as universities in Finland are under the Ministry of Education. VTT's mission is to work close cooperation in applied research together with industry. Our turnover is 244 million euros, of which about 45% comes from abroad. We have rather strong IPR portfolio, over 440 active patent families these days. As already mentioned, research content and solutions is at the core of responsibility at VTT. We develop sustainable solutions for customers and for society, and our research content and solutions is at the core of responsibility at VTT. We have incorporated the principles of sustainable development into our research and service activities, reporting, and internal activities. We want to become carbon neutral by 2030. In flexible and printed electronics research, we have these days about 110 people working, and people are located between Oulu and ESPO. ESPO is here in southern Finland, located close to capital city Helsinki. Oulu is about 1 hour flight north at west coast and about 150 kilometers south from the polar circle. Research teams are flexible electronics integration, printed electronic processing, which both are located in Oulu, Flexible Sensors and Devices team is in ESPO. Biosensor research team is both in Oulu and ESPO, focusing to diagnostic systems as well as tailored antibody development for diagnostic and analytic purposes. Our research priorities are listed in 4 major topics. First, and the key driver, is sustainable electronics, replacing fossil-based materials with renewable, compostable, and recycled biomaterials. Second is the flexible and highly stretchable electronics for wearables. Thirdly, we are looking to structural electronics, where electronics and photonics functionalities are integrated into plastics, glass, laminates, or other structures. Fourth is biosensors and diagnostic systems, where we focus on photonic and electrochemical sensing platforms as well as tailored antibody development. Our major goal is to scale up large area manufacturing and system integration technologies from laboratory developments to pilot level roll-to-roll fab processing. At VTT, we have unique roll-to-roll pilot production facilities, and as mentioned, our major offering and goal is to provide services to scale up production. We have been doing investments to these facilities almost 20 years. And as you can see here in the top left corner, we had our first roll-to-roll pilot printing line called Pico already 2003. Unfortunately, the device is old and we have sold it out. Today we have several printing machines, assembly and bonding machines, converting machine, different high power and ultra fast laser systems, testing and injection molding machines. Despite the COVID-19 pandemic, we've managed to finalize 2 new investments during last year. We installed a high-resolution reverse offset printing, which is capable to print submicron features. Here you can see an example of conductive silver grid with about 2 micron conductor width. Also, the registration accuracy is very good, about microns depending on used materials. Second new installation was the Silco elastic material roll-to-roll process line, which is dedicated to process elastomers and PDMS materials, mostly for wearable and diagnostic batches. There are several global and European sustainability actions, such as European Green Deal and United Nations sustainability goals, that force also electronics industry to think how to decrease environmental impact of their products. This is also supported by particular industrial trends. First of all, the global electronics waste is increasing rapidly, with only 20% of this is recycled property. This means that valuable components and materials end up in environment, and many of these can be toxic. At the same time, the global consumption of materials is expected to more than double during the next decades. New type of electronic solutions are also emerging that at some point of their life cycle end up in biological environment, either in purpose or accidental. Examples include sensors for intelligent packaging, environmental monitoring, disposable diagnostics, and precision agriculture. As a result, all this makes electronics industry to think if we are running out of some of the rare materials and valuable materials. So alternative materials might be needed based on renewable sources, or the materials from electronic waste should be reused more efficiently. From research point of view, there are several drivers and tools for sustainable flexible electronics. There is need to explore forward new functional properties and improve performance of novel materials. For example, nanocellulose is very interesting from electronics and photonics point of view. There is need to explore for end-of-life solutions as well as reduction of carbon footprint. Limited availability of raw materials is driving to investigate possibility to use abundant and cost-compatible materials. Important is also to look forward energy and material-efficient manufacturing processes, utilization of renewable materials, as well as design aspects like eco-design and circular design, and focus on recycling, reuse, and repair. At VTT, our research topics towards sustainable solutions for flexible electronics are renewable, bio-based and biodegradable substrates and over and injection molding materials. Abundant materials for conductors. Main aim for us is to get rid of silver. Different functional components and materials based on intrinsic material properties, as well as sustainable powering solutions like biobatteries and biofuel cells. Next, I'm presenting a couple of examples of our research in these topics. First, I'm introducing sustainable structural electronics based on form-forming technology. Here, the images illustrate the process from left to right, starting from forming, sheet forming, pressing, and final product. Here at the right side is our pilot line for the form-forming process, located in Jyväskylä. In this technology, generation of aqueous foam and mixing of raw materials in the foam is done in a tank or online in a tube. Then web forming is done, spreading the foam on a wire through a nozzle and removing wet foam with vacuum. Wet pressing is done next to increase the dry solid content of web to 40 to 50%. Drying is done with contact or non-contact techniques. The whole process can be done in batch or continuous roll-to-roll process. Here at the bottom, images illustrate different densities of embedded LED stripe inside this foam structure. This product image illustrates quite nice how does this product looks after the process. We have demonstrated different large area interactive acoustic LED panels with this technology. The process starts by printing of the backplane of electronics. Here is the rotary screen process. Then we do the LED and other passive component assembly on the backplane. After that, we run the LED foil with the components through the form-forming pilot line, where the LED foil is embedded into the foam structure. The interactive acoustic panel demonstrator shown here below and here at the right side includes integrated LED matrix panels and a grid eye infrared sensors for people flow detection. As you can see here, the LEDs are lighted. On the both cases here we have the RGB solution. We have also demonstrated different foam embedded Wi-Fi network blocking, reflection and beam steering functionalities at 2.5 and 5 GHz frequencies. The next example illustrates utilization of biopolymers in structural electronics. Here on the left-hand side, we have demonstrated printed and hybrid integrated LEDs on polylactic acid films, PLA, and overmolded with recycled PET. These results are published in the International Journal of Advanced Material Technology last year, and you can find more information from the publication. In this research, the aim was to explore sheet level printing and component assembly on these PLA films, and then furthermore look to overmolding to use the recycled PET material. Here you can see the next example. Here the aim was to scale up the process towards roll-to-roll manufacturing on the PLA films. Here you can see some photos, first on the rotary screen printing process and assembled LEDs on the PLA film. These results were published in Journal of Plastic Film and Sheeting Journal earlier this year, and you can also read more details from this journal mentioned here. Next example is a demonstrator about printed paper-based hybrid electronics. This demonstrator comes from the SuperSmart project, which was funded in EIT Raw Materials program and was coordinated by Fraunhofer ISC. The other project partners you can see here. Goal of the project was the industrialization of high-performance key materials in order to secure the electronic material supply chain, and environmental impact of the materials was key driver. During the project, we demonstrated a shock detection active tag based on piezo material to track product damage during the transport, and anti-counterfeiting label relying on an electrochromic display to authenticate medical or luxury products. The manufacturing of the demonstrator was a huge effort from printing point of view. It contains 12 different printed layers and chip assembly processes, and we managed to handle all of them successfully, and it is shown that it's possible to print rather complex printed hybrid system using printing and hybrid integration processes. You can check more details from the project website mentioned here. And also here you can see the pictures, one of the printing phases and this manufactured printed tag. Demonstrator also won earlier this year OEA demo competition with the category Best Publicly Funded Project Demonstrator. So there is a link also for this competition. Printed and flexible electronics relies from conductor point of view very much on silver due to high conductivity and relatively easy processability. However, from sustainability, it has limitation, and it is important to look towards other solutions. VTT has been working long time in graphene flagship program, and we demonstrated a graphene-based solutions for flexible and textile integrated electronics. Few years ago, we demonstrated the capacitive touch-sensitive electrode matrix on fabric based on screen-printed conductive areas. You can see the demonstrator t-shirt here. The graphene pattern array was printed on polyurethane thin film laminated inside the t-shirt. This electrode array is user interface to control other external devices. Here is the link for the YouTube video, which is illustrating the functionality of this t-shirt, and you can check it out later. Here in the middle below is a picture to demonstrate how these electrodes are also stretchable, and about 10% stretching of conductive wires without significant loss in conductivity can be achieved. So here is a picture how they are stretchable. Finally, I would like to introduce our national effort in area of sustainable electronics and photonics. The project is called Ecotronics and it is VTT coordinated. It is 4.2 million project running until end of this year. The project is funded by Business Finland. We have strong academic consortium with different Finnish universities shown here, as well as large industry group from SMEs to large enterprises like Stora Enso, GE Healthcare and Vaisala. In the project, we are aiming to electronic sustainability through several factors. Selecting highly recyclable and compostable materials, promoting environmentally friendly manufacturing technologies to reduce the use of materials, developing the methodology to recover the materials, quantifying the environmental impact of the developed solutions. You can check additional information of the project from the project website, and link is here. Here are more details about the contents we are focusing in the Ecotronics projects. We have a lot of different material developments on cellulose-based materials, paper coatings, bioplastics and biocomposites. Material development is in high focus, but we are also looking for how to utilize these materials in active components like supercapacitors, organic photovoltaics and diodes. We are looking for sustainable manufacturing processes for printing, hot embossing, overmolding, assembly and converting processes. The important topics are also life cycle assessment, how to repulp the paper and de-inking and get the materials recovered. We also focus on PCB design and testing on sustainable substrates. Okay, and finally, for summary, resource sufficiency is a global challenge concerning all businesses. Sustainability as a business approach is becoming widely adopted by companies and organizations around the world. Greener operations, products, and sustainable materials are the key. We are open to build up new cooperation partnership with academia and industry. And thank you very much for listening to these presentations. I'm happy to answer to your questions. So thank you very much. My contact information here is here below, so don't hesitate to ask and contact me later. Thank you.